how Tanzanite forms. It surprises me it's taken this long for me to get around to Tanzanite because it's actually one of my favourites. So we're going to explain exactly how Tanzanite forms in 5 easy steps. Setting, zoisite, vanadium, metamorphism, and exposure. Tanzanite, which is a remarkable material which is roughly 1,000 times rarer than diamond, exclusively forms in the Merelani Hills of Tanzania, where a very unique series of geological conditions are present. These conditions are going to include a combination of high pressure as well as high temperature deep within the Earth's crust. The area is part of what's known as the Mozambique Belt, which is a geologically active zone known for its very complex history of tectonic activity, which provides necessary conditions for Tanzanite to actually form. Now, you might have heard of the mineral zoisite, which belongs to the epidote group. Now, this is the base mineral for Tanzanite and forms in the Earth's crust from aluminium-rich rocks. During periods of extremely intense geological activity, such as mountain building, these rocks are subjected to what's known as metamorphism, which is essentially rock speak for change. The high temperatures and pressures cause the aluminium-rich rocks to recrystallize into what we know as zoisite. This process occurs very deep underground, where the rocks undergo significant structural changes over millions of years, i.e., metamorphism. For zoisite to actually transform into tanzanite, it must interact with vanadium, which is a heavy metal on the periodic table. Vanadium-rich fluids percolate through the Earth's crust, usually carried by hydrothermal activity or fluid movements associated with tectonic processes. When these vanadium-bearing fluids actually come into contact with zoisite crystals, vanadium ions are incorporated into the zoisite crystal's lattice. Now, this chemical substitution is crucial, as the vanadium is responsible for the blue-violet colour that we know and love about tanzanite. Without vanadium, the zoisite would remain in its typical greyish green or brown state. After the zoisite has successfully incorporated vanadium, the rocks will continue to experience particularly high pressure and high temperature conditions due to the ongoing tectonic activity that the area they're found in is very much known for. This prolonged metamorphism further alters the crystal structure and then stabilizes the blue-violet color that it's known for. The exact temperatures can reach up to 600-700 degrees Celsius, whilst pressures can exceed several kilobars, which, for context, is absolutely enormous. This stage ensures that the colour produced by the vanadium remains stable and intense, ultimately resulting in the brilliant hue characteristic of tanzanite. Over millions of years, the tanzanite-bearing rocks are gradually brought closer to the Earth's surface through various geological processes, which might include, but are by no means limited to, erosion or tectonic uplift. In the Merelani Hills, these processes expose the rocks containing tanzanite, making them slightly more accessible for mining. And I say slightly because tanzanite mining is notoriously difficult. Miners extract the tanzanite from deep underground, often digging extensive tunnels and shafts to reach the gemstone deposits. Once they're extracted, the rough crystals can be cleaned, cut and polished, and then sent around the world to people like you and me. I would like to thank everyone for the unexpected success of this series, and would politely encourage you to let me know in the comment section the minerals, crystals and precious metals that you would like us to cover next.